Yeah, I mean, today, hi everyone. Uh, Good evening, good morning, good afternoon. Welcome to this RSocket talk, and not just RSocket, but RSocket with Spring. Today we have Rossen and Mark. Both of them are part of Spring Framework and great contributor to Spring and Spring Boot and RSocket. Uh, Folks, please, Rossen, probably please do a short intro, if you can describe, yeah, what are you doing, and yeah, share some info about you.
My pleasure. Добро пожаловать. My name is Rosen Stoyanchev. I am a developer on the Spring Framework team. I focus on web development, so I've been involved with Spring MVC, Spring Webflux, and for the past year, I've been working with Oleg on RSocket as well.
Mark, welcome. Can you talk a little bit on what you're doing at VMware and how you help to develop Spring and Spring community a little bit?
Yeah, do you mind if I go ahead and just advance the slide? Because that way I can we can kind of launch into this and just get
Yeah,
started because I don't want to cover it twice. I mean, that's too much me.
sure,
My
absolutely.
name is Mark Heckler. I am a Spring developer and advocate. I do contribute code to various Spring projects. I also write code using various Spring projects, and I also get to advocate. So I get to talk about it and just chat with developers around the world doing different, unique, and interesting things with various different Spring projects, Spring components. I am an author. I've co-authored a couple of books, contributed content and code to several others, and have another book in the pipeline. Effectively done. I'm just doing final edits and revisions now, which I'll point out in a moment. I am an architect and developer by background. I am a Java champion, Java 1 rockstar, groundbreaker ambassador, also a Google developer expert in Kotlin. And I am the sole creator and curator of Spring Noticias en Español. That's just a passion and personal and professional project of mine to help spread the good word of Spring and just in general, Java, Kotlin, Maven, Gradle, anything related in Spanish, because that's another language that I do speak, even worse than English. So, I appreciate people's patience. I am also a licensed pilot, which I'll show you some things that kind of tie in with that, because we're always, there's always an issue of what domain do you use when you're creating examples. So you're going to see some pilotage type stuff in there. And of course, the book that I'm working on and effectively finished, just revising now, is Spring Boot Up and Running, or How to Build Cloud Native Java and Kotlin Applications. I do cover some RSocket in there, some reactive stuff, and just a little bit of everything else to kind of provide a not just an introduction, but also just to kind of like dive into areas that are frequent hotspots. So if you're interested in knowing more, maybe checking out a quick 10 or 20-day free trial to get access to the so far unedited chapters, you can follow the link there and check it out if you wish.
All right. Hello, everyone. I guess most of you have already known me, and yeah, my name is Oleg. I'm software engineer. I just recently joined the VMware team and basically the Sprint team. So technically, I'm not a part of Sprint team and not yet Reactor team, but I will be part of those team in a couple of weeks. So. Yeah, I'm most of the time I'm doing I'm a big fan of reactive programming and reactive streams. I started working on Project Reactor, contributing to this project, and nowadays I'm trying to drive the RSocket project, develop everything which is included in the RSocket Java, improve performance, and of course advocate all this stuff. So yeah, this is basically about me. So probably let's talk a little bit about our socket beats, because today we will be talking about RSocket and of course about RSocket with Spring. So just to start and just to remind you what RSocket is, and yeah, I just want to do a short intro into and like just to remind you what RSocket. Uh, RSocket is a network protocol. If you have never heard about this, RSocket is a layer 5, layer 6 network protocol. It's cool because it's cloud oriented, and everything we do with the sort of cloud, of microservices and distributed system. And believe me, that's the main idea of RSocket, because the original engineers that was stand behind this protocol was a part of great companies like Netflix, like Facebook, Alibaba, and of course Pivotal. Nowadays it's part of VMware. And yes, those folks knows how to build real really good solution designed for performance and for microservices, of course. In general, the main idea of RSocket is reactive streams as a network protocol. It brings reactive stream semantic as a first-class citizen. It's focused on resilience, and yeah, that's what you have to know about RSocket. In general, just to remind you, we had a lot of talks on RSocket at different conferences, and if you wish, you can look at those conferences, but I don't want to spend much time on explaining all the bits about RSocket. So yeah, let's move forward and let me just quickly introduce what we have at RSocket nowadays. So RSocket is just a protocol. It's designed as peer-to-peer protocol. It brings you normal communication styles like streaming, request response. It has flow control, so you can control your data stream like in real reactive streams. It's focused on resilience. It brings something called leasing, which basically rate limiting, in other words. It has resumability. It has many other features which you may appreciate, in which you can be really excited about. And yes, you can use it nowadays, not in Java, but in many languages, as you will see. So RSocket let you use any data type, any message format. You can use any messaging style. Today we will be focusing on Spring messaging and Spring, so you will see how you can build your API on top of RSocket using Spring capabilities. And of course, you can use it in different languages, which means that we will start from Java, but probably you can easily continue your microservices at Kotlin, at JavaScript, at any other language that we support in our portfolio. And finally, the main idea of RSocket is to bring flexibility, not only through the protocol features, but of course through the transport features. So basically, RSocket let you run itself on top of TCP, WebSocket, HTTP2, Aaron if you need a little bit more performance. Yeah, that's basically it. Just a couple of words about, for example, Java side. That's how we can build an RSocket server on the Java side. So the main things that I want to explain here is basically payload is your data layer. So probably if you will wonder what is payload, payload is your message format, your binary message, in which you can encode basically anything that you wish, JSON, protobuf, anything. Then the second layer that we noticed is your communication layer, basically the RSocket API. And RSocket API let you doing basically anything you wish. It let you stream in, or it let you do request response. Everything that you wish can be defined using just RSocket interface and RSocket API. And then, for example, in RSocket Java, we are using Project Reactor for convenience. So you can use fluxes, monos, or any other reactive streams-based library in order to do your messaging. Finally, what you need to do at the last step, you can use any transport. And at this example, what I want to just emphasize is that, as you can see, transport is not binded directly, is not coupled with your business logic. So you can write your business logic once and use it on top of everything, which is really cool. This is the flexibility which is brought by RSocket. Finally, for example, on the client side, you can do almost the same, because RSocket, as I mentioned, is peer-to-peer protocol. So in theory, you can even define your acceptor or logic which going to be handled by your client if server decide to ask you something. But in general, the API is the same. So you can connect to any transport. You just need to define the endpoint, features that you want to use on the client side, and that's it. So at the end, you can use your RSocket in both directions. You can define your business logic, as well as you can use it for requesting. Request stream, you get your flux, and you can process your data as you wish. So this is a short intro into RSocket. We just spent really a couple of minutes in order to let you remember how RSocket Java looks like, what you can do with RSocket Java, and basically the same API and the same ID is hidden in the other languages. So once you start with RSocket Java, you can easily switch to other language implementations without any problems. But today, our focus is Spring, our focus is messaging, our focus is building real application. So Mark, please take the stage and let's talk a little bit about RSocket and Spring.
Okay, well, thanks, Oleg. Actually, I like to lead in with this because this is hopefully not how this turns out. But on the other hand, RSocket is kind of on fire, right? So I don't know. Anyway, we'll go with that. All right, so let me close out of the slides. Okay, so we've got this. Everyone can still see my screen, right? Oops. Let's see. Let's change that. And everyone can see the Spring initializer? Yes? No? Oh, good. Okay, I like to confirm before I just launch in, and then 5 minutes later, someone says, "Well, we don't see anything." All right. Okay, so this is going to be a rather quick introduction, as Oleg said, but as I like to call it, full throttle. But I do want to kind of jump in very quickly, but not so quickly that it just, it's too fast, because I want to make sure we cover everything well. I'd rather cover a little less and cover it well than cover a lot more and cover it poorly. So, but we will be proceeding apace. So I'm going to just start off by creating a couple of projects here, and going to be creating RSocket enabled Spring Boot applications. And I'm going to keep it pretty simple, just as far as the framing of it, if you will. I'm going to create a Maven-based project and use Java for the language and the current version of Spring Boot. And I'm going to change the group out to the Hecklers, because I always do that, and it never works if I don't. I'm kidding. So we'll call this our RS server. And by the way, I think Oleg mentioned that and if not, he will mention later, but I do want to cover that that the construct of client and the construct of server is a bit, initially it's important, right? Because your client needs to connect and initiate that connection to the server. But once that connection is established, they are effectively peers. Communication can be initiated from either side. It really does not matter once that connection is established. But initially, of course, it matters. The client needs to reach out to the server, and the server needs to be listening for those connection requests. So I'm going to be choosing jar packaging because, again, it is, the 21st century, and jar packaging allows you to do some intelligent things looking forward without the encumbrances of an application server. I'm going to be using the current version of Java, the latest, greatest, which is 15. Not essential. We do baseline at 8. We support the current LTS version of 11, but 15 lets me do a couple things that I hope to be able to do if IntelliJ plays well with me today. We'll see. So I want to bring in the dependencies for RSocket, as well as Webflux. Webflux typing is already down the toilet, so we'll see how this goes. And Lombok. Lombok allows me to reduce boilerplate code, as it says. I'm a lazy developer, lazy in a good way, hopefully, especially for demos. We can debate its use for production software, but for demos it works well because it allows me to focus on the important things. Oleg also mentioned that RSocket is built around reactive streams publishers and specifically Project Reactor, so fluxes and monos. And just for those who may be coming into this a little bit cold, a reactive streams publisher, reactive streams has 4 interfaces: a publisher, a subscriber, a subscription, and then a processor, which incorporates both the subscriber and publisher. So it takes values, manipulates them, and passes them on. But within Project Reactor, we specialize. So we specialize publisher into 2 different specializations. One is a mono, 0 or 1 value, and one is a flux, which is 0 to n values. So it could be a small set, it could, or a small collection, an iterable, effectively, or it could be an unlimited number of values that arrive over an indeterminate amount of time. But that kind of parallels what we have in the imperative world, right? So if you return from a method a value or an iterable of values, you have one or many. And of course, if you specialize publisher into mono, 0 or 1, or flux, 0 to many, right? This kind of makes a lot of sense. So I'm going to generate this project, and I'm just going to save that to my desktop. And I've got a bunch of junk on my desktop, but that's fine. We'll save that. And then just in the interest of time, I'm going to change this to client, and we'll do the same thing. We'll generate that project, and that's fine. And I'm going to go ahead and unzip this. And I'm trying, I forgot to start my timer. I want to try to make sure I stay within, or at least somewhat close to time. We'll try that. We'll hope for the best. So get rid of this stuff, and this, and this, and this, and trash. That's perfect. Okay, so now we're off and running. Cleaner setup here. All right. So this is our server project, and I'm just going to close that out and open up my application properties, which I will get to in a moment, and the application code, and close out our get ignore. We really don't need that, and I will scoot that over there. And then I'm also going to go back and just open up my client project. And by the way, if anyone isn't familiar with the Spring Initializer, it doesn't generate code other than your main application class, main method. But what it does do is it generates your project. So it gives you a kind of a running start on your project. So let's see, why is this, where did my, here we go. And it is just not showing up. So let's see, we'll maximize that and bring that over and bring that over. Perfect. Just a few simple steps. IntelliJ is giving me grief this morning, so I'm sure it'll be fine. So again, application properties, application class, and we'll close this. And now we're set. Okay, so for our server, now RSocket straight Java implementation, straight Java API
So,
is
Mark,
wonderful. Yes.
May I interrupt you for half of a minute? Could you please increase your fonts, if it's possible,
yes.
of course?
Oh my goodness. Yes, I'm glad you mentioned that. I thought to change it to the high contrast for visibility, but I forgot to change the fonts here. So yes,
especially because we have picture-in-picture. So and your screen share also.
Oh my gosh.
Oh, okay.
So let's go to bigger, and we'll see if that works. Is that sufficient?
It is better, and the same in the browser if you have to place to share with the browser. So the same.
Goodness, yes. Okay. Yeah.
Thank you very much.
Remembering that.
Okay. Okay. That's it from my side.
Right past that.
Okay. Thank you.
Okay. So is that sufficient? I can blow it up more, but then of course there's less text on screen. Okay, we'll go with that. If anyone has problems reading it, just let me know. So the Spring Boot API, actually, Spring Boot and Spring in general is known for opinions and trying to find that 80 to 90% of use cases and make things dead simple coming from that perspective. So one opinion that we have is, of course, that all applications should start up by default on port 8080. Now I'm going to go ahead and set my server port, in this case to 9090 for my RSocket server, well, for this application. Because that way I won't have port conflicts when another application starts. That's always a little awkward. And then I'm also going to set up my RSocket, typing is a problem, port to 9091. And simply by doing that, that effectively tells, with that single property we're setting, that tells our Spring Boot application via auto configuration to set this up as an RSocket server. So it makes things, again, super simple to kind of kick things off and get things started. Now, I like to create a configuration class to where I can create my beans in there, my Spring Beans. Now, you can have bean creation methods in your Spring Boot application class, because if you follow this is a meta annotation which includes a configuration, but I like to keep things separate. And in production, I would actually create these in separate files, of course. But just for the demo, I'm kind of lumping them in here. But I do like to still keep things separate. So we'll call this our server config class. And then I'm going to create a bean here, because from our RSocket server application, I'm actually querying another application, a box that I have that listens for air traffic in my area. So it's a small box with a small antenna and a small range, but it does get any airplanes that are flying locally, their ADS-B transmissions, their position reports, and I am able to use those as real data in my demos, because fake data is fine, certainly okay, but real data is better, right? So I'm going to create a web client so that I can so that I can query my application and ADSB box here, my plane finder box. So return web client create, and I'm going to point at that, which is running on localhost 76334, and I'm going to point to the aircraft endpoint. All right, so that gets me what I need here. And now I need to have established my domain model. So I'm going to create a class here. I'm having to look around my mic to find my keys just to center my fingers on the keyboard. So this will be an aircraft class, and this is an aircraft position, so it's an aircraft and its current location. And within that, of course, we will track things like our call sign, aircraft call sign, and our registration number, and our flight number, and our type of aircraft. And then we want to track our aircraft's altitude, current altitude, its heading, and its speed. And we want to also know where it is, right? So Latin lon. And of course, as I mentioned, I'm a lazy developer. I'm going to use Lombok for that. So Lombok, by annotating this with that data, Lombok will create the getters, the setters, the equals, hash code, and toString methods. And then, of course, there is actually more to this. Let me see if I can get to this. There is more to this. So it feeds a lot of data here. I don't necessarily want all of that data. So I'm just going to filter out anything that's unknown and just pull in these particular data fields. So what I want to do today in the short time that we have together is to show a few different things here. So let me, I want to make sure my timer is running right and I'm not exceeding my runway. So, all right. So what I want to do is create a controller, right? A controller. And this will be our aircraft server controller. And I want to, we're going to define a few things. So I want to demonstrate the 4 different interaction models, specifically of RSocket, and maybe a couple other things should we have time. But the first one is your typical request response, right? And then we will also take a look at request and stream, because you may want to send a single request and get back a lot of stuff, right? And we'll cover that. We also have fire and forget. So if our client, at least nominally our client or one of our other applications connecting to this RSocket server wants to just send stuff and not worry about it, just send it and fire and forget. That's what we'll cover also. And then of course we want to address a bidirectional, line up the keyboard here, directional channels. And that allows you, it does what it sounds like, right? It allows you to send things back and forth between the two different endpoints, if you will. So we'll start with our request response, and we're going to be getting a single request and providing a single response. And as we mentioned, it all kind of centers around monos and fluxes. So we're going to respond with a mono of aircraft, right? A single value, a single aircraft entry, aircraft position report. So we're going to return that. We'll say we'll call this resp, and we will get a single request and provide a single response. Now we'll say this is a single, a mono of type string, and we'll call this our, we'll pass in a timestamp. So timestamp mono. And I should say that actually with Spring Boot, it does automatic type conversion, so you don't necessarily have to deal and specify this to this degree, but it's super nice, and it's good to get into that habit of doing things, because that is effectively what you're going to be dealing with underneath anyway. So we're going to receive a timestamp. So we're going to return a mono. Now I want to, let's see, return, and we'll take our timestamp mono, and we will do on next. So we'll take our timestamp and let's just log this, right? So we'll log this. And I like to insert things that makes it a little bit clearer what you're seeing. So I'm going to put the little clock there, and we'll take our timestamp. And then once we get our mono value in, then we will provide a then, because that takes a mono and returns a mono, right? And then we need some way to query our plane finder so we can get our list of planes. And we're going to do that by injecting our web client that we created, our web client Spring Bean above. We'll call this client. And of course, we can do that via field injection, but that's kind of that's kind of unseemly. Or we can do it via constructor injection. And we can write our own constructor, or again, being lazy, and since I have Lombok, I'm going to just have Lombok create a constructor for me with a parameter for each of my member variables, all args, right? And that's, since we have one, it does that. So I'm going to take then, right? So we'll take our, we'll expect a publisher here. So we'll just do a client.get, and we'll retrieve values. And then we will convert that body to a flux because we're getting back a flux of type aircraft, right? And then I'm just going to grab the first value off of that and return that. So that's pretty clean, pretty neat. Now I just need to, well, we'll go ahead and start that up, and then I'll hop over here to my client, and we'll do some things here. So I'm going to set my server port, in this case, to 8080, and you don't have to do this. Again, this is a default, right? So yeah, I just like to show that. And let's see, do I need to do anything else here? I don't think so. Let's just launch on into here. Okay, so once again, we have our configuration class that I like to create, and this is our aircraft. Well, we'll call this our client config. And I'm going to create a bean here, if I can type. And what I want to do, or what I need to do, is create an RSocket requester bean that I can use throughout. And we're going to inject our RSocket builder that is already provided for us due to our class path having RSocket as a dependency. And I'm going to just use that to return builder.tcp. So we'll use TCP initially for our transport underneath. And we're going to point to localhost for our machine, our host name. And then 9091 is our port that we're running our RSocket server on. And that gets us set up there. Now, I do want to switch back here. And just in the interest of time, I'm going to do something that I feel a little embarrassed by. But nevertheless, again, due to tight clock, I'm going to just copy paste that. And please don't tell anybody. At least this isn't recorded, right? Okay, that's fine. All right. So here is our domain. We have our aircraft that we're going to be hopefully receiving back due to our request. And I'm going to, in this case, create a component. And just again, for simplicity, we'll call this aircraft client. That's fine. And I'm going to just create a post construct method, and we'll call this request response, cleverly enough. And let's see, so I need to inject, once again, my RSocket requester, and then once again using Lombok to make that a little simpler. And then here, I'm going to just do a requester.route, and we'll pass our route here, which I guess it would actually help if I did a message mapping here. So this will be request response route, and we'll restart that. You have to define the route, right? So it knows where to go to find what it needs. So we will do this, and we need to provide some data. And as I mentioned, I'm just going to provide a timestamp. And of course, data, I should say, actually data is optional. But it's nice to have, that way I can show you here what's coming through and verify that we actually do have what we're hopefully getting. So, and then I'm going to retrieve a flux. Actually, I'm going to retrieve a mono, right? Because we're just returning a mono in this case. It's a single request, a single response. And it's a mono of type aircraft, right? And yeah, so that should be it. And then, of course, what I want to do is subscribe to that. What I need to do is subscribe, so it kicks off the action. And then I'm going to take my aircraft, and I'm just going to print that out. And it's a single aircraft, so I'm just going to do that, and plus AC. Nice. All right, let's try that and see what we get. Okay, so we see here that we got our timestamp. See if I can zoom in there. So we have our timestamp that came in from our client to our server, if you will. And then we got back a single aircraft position report, right? Exactly as we expected, a single request, a single response. So let's go ahead and expand this, this example to include a stream, request stream. So once again, I'll start off, in this case, I'll actually start off with a message mapping, and we'll do a request stream. And we'll return a flux of aircraft in this case, and we'll call this request stream. Come on, IntelliJ, Keep up. There we go. Once again, we'll expect a timestamp coming in. So we'll call this timestamp stamp mono. And let's see. So I'm actually just going to grab this. And we'll bring this down. Again, copy paste, but hey, whatever. And then I'm going to, in this case, do a then many, because we're going to expect to return a flux, as you can see here, instead of a mono in this case. But once again, we'll do our client get, our retrieve. We'll do a body to flux again, because we're getting back a flux of aircraft. But in this case, we're just going to leave it as that, right? We're not going to grab the first one off that. We're just going to return the entire flux. Restart that, and we'll go over here and we'll create the same basic method here. Now, I probably should annotate these, but I think you get the point. So post construct, this will be our void, plus I do like to name these request, stream. So it's a little more descriptive. So requester.route, I'm going to point this to request stream. We'll provide our data once again of an instant.now, and we will retrieve, in this case, a flux of aircraft. And I'm going to, again, subscribe. And in this case, I'm going to take each aircraft, and in this case, once again, we'll do, of course, I'm going to assume and know that we're going to get back potentially multiple aircraft. Now, again, a flux can be 0 to n, so maybe we will only get back, well, no aircraft or one aircraft, but we assume we'll get back a bunch of aircraft positions. So we'll test that out, test that theory. Oh, look at that. Okay, so we issue our single request. Here's the timestamp for that request. So that's coming through fine, and we get back actually a grouping. So looks like we have about 6 aircraft position reports coming back for each request in this case. So that works pretty well, as we would expect it to, because things always work perfectly in live demos. Okay, so now we can move on to the fire and forget, which in many ways, in some ways, of course, seems like the simplest of examples. Let's find out. So fire, forget, except typing. And now, in this case, fire and forget is what you would think it would be, right? You send something from the client to the server, and you don't expect or wait for a response. You don't care. I mean, it can, it doesn't matter coming back to the client. It just matters that the client sent a value. So we can, what I like to do though is assume a mono void return type, if you will. But I'll show you something here in a minute. So fire and forget. And of course we get a value. In this case, I'm going to get a mono of type weather, because I'm going to be sending weather values back, weather mono. But of course we haven't defined weather, so we probably should do that. So I'm going to once again create a class. We'll create an all-args constructor, or make Lombok provide us with an all-args constructor, and we'll call this class weather. And of course we have I'm going to get a timestamp, if you will, for when the weather observation was. So when, and let's say string for what the observation is, the actual observation, if I can spell correctly. All right, so we now have our weather domain. We're going to take in our weather mono. So we'll do our weather mono, and then we'll subscribe to that, and we'll take our weather and do, so we'll assume now that there we go. We'll assume sunshine. Why not? Oops. Let's make sure we put that in quotes. That works a little better. The tight screen is tough, but I do like to show that. And of course, since I'm saying that we're going to be, quote, returning a mono void, we can just do a mono.empty. And of course, we can just comment this. We can just change this to void, and everything's happy. The thing is, though, I do like to keep things in mind in terms of that Project Reactor type of model. So I do like to kind of list it that way, but do what makes you happy. I'm also going to copy this over so I can have my domain and duplicate that here at my client very quickly and easily, expediently. Okay, so we have our server up and running, and that seems to be fine with the fire and forget. Now to create our fire and forget example or method here. So we'll do a post construct, void, fire, and forget. And typing, there we go. Okay, so we'll do a requester.route, and we call this, or the route again was fire forget. And we will do the data in this case. So we'll do a new weather object. So our weather value, we'll do an instant.now for our reading, weather reading. And then we need some kind of a value. So I'm going to say skies clear, and the visibility is 12 statute miles. And that's how we do it here in the US, is what it is, right? And I'm going to, since I've provided that value, I need to send that, which produces a mono void, and then I need to subscribe to that. And of course, that should be enough to get us going. Let's run that. And as you can see, we're expecting nothing back, and we get effectively nothing back. But here we have our weather report. So the timestamp and the observation itself. And everything is working just fine as we would expect with our fire and forget. So let's see, our timing looks good. Ah, that's great. Okay, so this is one of the cooler parts, and then I launch into another cooler part and then another cooler part. So yeah, be that as it may. So for our bidirectional channel, this is exactly what you'd think it is, right? It is a bidirectional connection between the two different or multiple different points. In this case, our RSocket server and our RSocket client. So we'll be returning a flux, in this case, of aircraft, right? And we'll call this channel. And again, I skipped over my message mapping. We'll call this channel. Yeah, so that's fine. And then we'll be receiving a flux of weather, right? We'll call this our weather flux, cleverly enough. Okay, so we'll take our weather flux, and what I actually want to do, I'm going to just go to the next line so we get a little more space. I want to indicate our do unsubscribe, so I'm just going to say subscribed, so we can kind of see this. Subscribe to weather. Typing is good. And then on next, I want to take my weather report. And once again, I'm just going to print that out. In this case, I'm not going to say it's all sunny. We'll say it's maybe a little windy. We'll go with the windy guy here. W. And then we will switch map. So we get in values via Flux. We're also going to produce our values going out. So we'll again do our client.get, and we'll retrieve values, and we'll convert that body to a flux of aircraft. And yeah, that should do nicely, right? Very nice. Okay, so let's restart that. And what this is doing is expecting weather to come in a flux, a publisher that is potentially open-ended, and it's sending back each one it gets, each value it gets of weather, it's sending back a listing of current aircraft positions. So once again, we come over here. There we go, just like to keep things consistent. And we'll do a post construct void, and this is our channel requester.route, and we're going to point to, again, our channel, and we will, in this case, send data. Now, what I actually want to do, though, is send a flux. So I want to create some interesting values in this case. So I'm going to create a list of weather elements or observations. So we'll once again go with sky clear, viz 12 statute miles, but we also have other observations. So overcast at let's say 800 feet, and visibility half statute mile, and then let's say broken at 8,000, and visibility 10 statute miles. So that works. Now let's go ahead and introduce a local variable, and we'll call this obs list for our list of observations. And you know what I did not do is change this in IntelliJ. Hopefully IntelliJ will play well. If not, well, we'll just roll on as we have it. That's not a big deal. but I do like to clean things up when possible. So let's see if, oh yes, yes, so nice. Okay, so I'm also going to create a random variable, new random, and that looks fine. So now I can take my data and do a flux dot interval, and I'll create a flux at a certain interval. We'll say this is an interval of 1 per second. And then I'm going to map. Oh, let's see. It's tough when you can't see what you're doing. There we go, duration. And map, and we'll take each of those pings, and we'll use that to create a new weather reading. And of course, using instant dot now. And our we'll do our obs list, and we'll get a value from that. We'll use our random to grab the next int, and we'll bound that by our size of our observation list. It's so simple, right? And then we will retrieve a flux. So we're sending a flux of weather readings. We'll retrieve a flux of type aircraft, and we'll subscribe to that. And we'll take our AC, and we'll do a print line. And in this case, of course, since we're getting back a different listing, we'll say that these are use. Come on, there we go. IntelliJ is just wanting to play with me a little today. That's cool. We can play. All right. So let's try this. This should work, right? I mean, I haven't fat fingered something, but it seems happy, so that's a good start. Oh, I thought it seemed happy. So let's see what I have here. Oh, it's actually coming up with a problem connecting. So let's go to here. And yeah, well, that would cause it, right? Downstream. So let's, or upstream in this case. Let's go ahead and restart that. Okay, that seems quite happy. So let's see if we've got this running. So let's go ahead and restart this. Oh, it looks a little better. Yeah, I'm not sure exactly what happened with my my feed, but yeah, blame it on the feed. It is the feed, so in this case, it makes sense. All right, so we got our subscribed note. We also are getting in our weather flux or values via our flux, weather flux, and we're getting back our values here of our aircraft polling. So that's pretty cool. So we're getting that bidirectional feed. Now, actually, when I do this, I forgot to throw in something here to address some of this messiness here. So I'm going to just do that before I get any farther down the road. Hooks dot on error dropped, and we'll take our error and we'll just do a so disconnecting error get localized message. Okay, so that'll make that a little bit neater here when we restart. Okay, now. Because what it's doing is basically telling us, hey, we've disconnected. I'm just going to clean that disconnect message up just a tad. So now one thing that I like to do is show that we can actually have a lot going on at the same time, because again, this isn't just this shows you the bidirectional aspects of it, but I do like to kind of show off that you can have multiple things going at the same time, which is, I think, kind of cool. So I'm going to enable scheduling, and I'm going to create another component, and we'll call this all args constructor, and this will be our fire and forget component. Why not, right? And so I'm going to schedule a method here to execute at, let's say, once every 3 seconds, just to keep it real. And I'm going to grab this, and we'll just bring this down, because I like to create chaos where I can, and I think it's instructive. So, and once again, we need to inject our socket requester. And there we are. So now what should happen is that we should start this up. We should exchange weather information for aircraft listings, but we also should be doing a fire and forget. So we're just creating this bean that'll sit out there, and every 3 seconds it'll send a weather update back to our server. And this is a very simple use case, but I love how it kind of shows the different, the multiplexing, if you will, the different components that are using that same connection. So here we've got our weather. You can see the different, and that's one of the reasons why I like to include the icons, the emojis, because it shows you each different thing that's coming through once every 3 seconds for our fire and forget component, and then every second as we expected here. Now, I do have just a couple of minutes left. Oh, well, I don't, but I'm going to go ahead and squeeze this in anyway because I think it's very instructive. Oleg talked about how that we aren't dependent on our underlying transport. So I'm going to just show you this. Our transport, we're going to change this out to WebSocket, restart that. And then I'm going to go over here and do a slight change here to my builder. And we're going to have our RSocket requester. Actually, I don't even have to do that. So return builder.websocket, and we'll do our URI.create, and we'll point this to http://localhost host, and it's 9091. And let's restart this. And everything works just the same. So hard, right? I mean, this allows you to focus on the things that you need and want to focus on without necessarily caring to the degree that you would have to in other cases, how you configure the underlying transport. It just works. Okay, so I'm officially out of time on this segment. I need to turn this back over to Oleg, and then we'll go into some kind of wrap up, some great announcements coming up, and then some Q&A. So Oleg, it's back to you. So let me switch back to the slides, start them, and then it looks like you should be able to, you should be able to control it. Awesome.
Yeah, let me try it. Okay, come on. Yeah,
perfect.
It works. Looks like it works. So it was great intro, Mark. We started from really simple example of RSocket Java, which was like just something about RSocket, definition of the server, definition of the client, some configurations, which is of course not always convenient for many users. Definitely no definition of routing because RSocket is not aimed to bring all the features that you might need in real application, but it brings a building block that then you can use in order to build end-to-end reactive system using real-time messaging over reactive streams. And of course, the main idea, just to emphasize and just to remind, is that RSocket is reactive streams is a specification, it's a network protocol, which basically let you transparently send your stream, and that's what you've seen in the Mark demos. The sprint part, just to summarize, brings another layer, the application layer, on top of RSocket, which let you build your application using well-known, convenient Spring way, using annotations, using controllers, using your request routings, and using just simple input and output definition. You can define your type of communication, which can be request response, fire and forget, request stream, or even bidirectional streaming from both sides. So as you've seen, RSocket is not just another protocol, but it's even more with the support of Spring Framework and Spring Boot, which is awesome. And yeah, I have to say, you can easily migrate from your Spring Webflux to Spring messaging without any problems. Just rewrite your annotations. That was great, and I really like what Spring and Spring Boot offers to RSocket community, of course. But yeah, let me do a short outro and basically talk a little bit about latest RSocket news, because some of you are pretty new to RSocket and you just learned something interesting and how to use RSocket with Spring. But maybe some of yours have already get some knowledge about RSocket and you are wondering what's going on in the project, what are our plans, and what is the latest news. So let me do this sharing for you. First of all, some news about RSocket Java, and the greatest news about RSocket Java is that we just recently got 1.1 version, which is super awesome. Why it's awesome? Because it has improved performance. We measured, of course, using Java micro benchmarks, test suite, and we have seen that our performance is almost 10 times better in terms of throughput and latency compares to the previous generation of RSocket Java library, which was 1.0. And that's great because now you have better performance. You can build high throughput and high performance application using RSocket Java, which is great. A part of that, in the new RSocket Java, we introduced new a little bit better user API, which is available through RSocket Client API. And RSocket Client is basically another way to do your communication. As you remember at the very beginning, I have shown that we have RSocket interface, which can be used as your API on the server side in order to build up your business logic and so forth and so on. But on the other hand, you have to use the same RSocket API on the client side in order to initiate your requests, which might not be really convenient. On the other hand, there are many problems related to the fact that RSocket connector on the client side returns mono of RSocket, which is kind of something lazy. That means that you have to block somewhere. You have to wait for the resolution, and it brings a lot of questions and problems on how to share this instance, for example, inside your Sprint project as a bean and so forth and so on. Because once you have something lazy, you cannot use it as something and something physical and here and now. You have to subscribe, and probably if you subscribe multiple times to mono of RSocket, you will get multiple connections open. So for that purpose, we improved our API and we introduced this RSocket client, which basically takes this mono of RSocket and transforms it into something physical, into something that you can use here and now. And of course, it lets you easily do your requests, streams, and so forth and so on here and now without waiting for resolution. And of course, it ensures that the same connection will be used underneath, which means that now you can easily share your bean if you wish, or you can use it as RSocket requester, which wraps all this stuff under the hood. So this one of the main feature introduced in RSocket Java, but a part of that, this is the API of RSocket client, which of course, really convenient for many of us. I have to skip these slides again. But a part of that, one of the main features of RSocket Java is absolutely new load balancer API, which of course built on top of RSocket client, and which is designed for high performance, for simplicity in terms of resolution of your instances to which you want to connect, and etc. etc. So new load balance API looks like this. So you can easily use the same RSocket client. You can basically build your client side logic around RSocket client, and then it can be your default RSocket client, which can communicate with a single instance, or you can build up your load balanced RSocket client, which can use different load balance strategies. So by default, you can use round robin, but if you wish, we have really sophisticated weighted load balance strategy, which really smart and which is based on latency and many other metrics from your connections and communications. All right, that's some news about RSocket Java. But you may wonder, okay, what we are planning to do, what we have else. In fact, we are really actively developing RSocket for Kotlin, and here we go. We have, of course, not a final version of RSocket Kotlin, but this RSocket Kotlin version is really great because this RSocket Kotlin is rebuilt from scratch in order to support multi-platform. And it means that now you can use RSocket Kotlin on your for example, Swift side, in your Swift application, in your browser JavaScript application, and basically you can build your RSocket Kotlin app into native and run it everywhere, which is great. A part of that, RSocket Kotlin was rebuilt in order to support convenient Kotlin API like coroutines and flow. So yeah, this should be really familiar for many Kotlin fans. A part of that, what we are planning to do, because this is important for many of you in order to understand what we are planning, what we are doing, and what we will get in the nearest future. So let me share some ideas and some information about the roadmap of RSocket. So first of all, we are actively working on RSocket Spec 2.0, which is aimed on support of Quick Protocol. And if you have never heard about Quick Protocol, basically this is another implementation of TCP based on top of UDP in order to bring you really high performance. And of course, it means that once RSocket Spec 2.0 will be released, we will be able to support, and we will be supporting quick underneath as a transport for RSocket. A part of that, we are actively working on RSocket TCK. TCK is Task Compatibility Kit in order to simplify other developers joining our family and developing other language implementations. Yeah, of course, we are a small team. We are doing our best to support existing implementation in different languages and platforms. And of course, not of all the language platforms are supported by now. So in order to simplify building new clients, new servers, and new RSocket protocol implementations, we decided to heavily invest time into Task Compatibility Kit and simplify lives of other developers that decide to build RSocket protocol implementation in different languages, in different language or in the Java, but in a different way. Finally, we are actively focusing on JavaScript part, and we are planning to rewrite RSocket into TypeScript. And of course, we know that iOS family and iOS developers are eager about RSocket Swift. So we got a company that decided to work on RSocket Swift. So we hope that RSocket Swift will join our RSocket portfolio pretty shortly. So that's what we have by day, and that's what we are planning to invest our time in. And I hope that this convince many of you to spend your time on RSocket and invest more and probably rewrite your project into RSocket in order to get better performance, real-time streaming, and other benefits like resilience that RSocket offers to you. So that's basically it from my side. If you have any question, that's basically the right time to ask them. And thank you for your attention. Maybe you want to, Mark, add something from your side?
Yeah, I was just going to say that obviously this is evolving, right? And it's well established, well proven, but by the same token, we're constantly evolving this and expanding this. And while your help is also required, or encouraged and appreciated, if you just want to follow any of us for updates, tips and updates, if you want to check out the book, whatever, the links are all there. By all means do so. I will also post a code repo with just the code you saw here today and maybe a couple other things thrown in for good measure. If you want to ping me, I'll post that on Twitter and share that out later on today as well. But yeah, just engage, because it's a great community. It's a great project, and we're doing some really cool stuff with it. As you can see, it's really kind of nice. So solves a lot of real world, very difficult problems, and it's just a great time to get involved with that. So with that, I guess Rasen, we'll turn it back to you. And do we have any questions, comments, feedback at this point before we roll into the separate Q&A?
Yes, we do. Plenty of questions on the chat. I will start with a simple one. Mark, will the demo code be shared on GitHub?
Yes, and I actually had a couple of rough repos out there. I just wanted to clean them up a little, so I'll go ahead and get updates pushed here in a bit and share that. I can send out the thing via email, but email, frankly, I check Not very often. So the best way to find out about that kind of stuff is just follow me on Twitter, and I throw everything. I live on Twitter. I mean, that's kind of my life is laid bare on Twitter. So I'll share the code repo link on Twitter. If you just follow me at mkheck, is listed there on the screen, then you'll see the announcement. And by all means, take a look at it, kick the tires on it, and any feedback or PRs, or just use that as a leaping off point to do some really cool and crazy stuff.
Thanks, Mark. There's also a extensive samples set of samples in RSocket Java itself, so that's another source that you can check out. And there are plenty of RSocket Spring talks as well, so you can find quite a few resources on the subject by now. Our next question, or actually there were a couple of questions around running Webflux and RSocket on the same server. If I can say one extra thing in addition to the conversation. So yes, they're both running on Netty. However, for RSocket, we're using TCP as a transport or WebSocket as a transport. And Webflux is basically HTTP server, which can also run WebSocket. So technically, we could think about sharing, for example, the Webflux server running on HTTP with WebSocket and an RSocket server running on WebSocket. Challenge is more around separating the namespace. So you need some kind of configuration to decide, which one is for Webflux, which one is for RSocket. And that's just not something that's supported at the moment, even if it's technically feasible. It could be done. It's just not supported at the moment. All right, the next question is, what problems RSocket solves, and what is a good example of when you should consider to use RSocket in production?
So yeah, let me jump in and answer this question. So yeah, to wrap up, it's basically what is a good use case to and when it was to use RSocket in production. I would say, like from the past, from the history, the really good use case is edge networking. So for those who have no idea what is edge networking is basically where you have your ecosystem, and when you have many different devices connected to your system, which can be browsers, mobile phones, and many others, and then you need things like performance, when you need things like resilience, then RSocket is a good answer for those questions. First of all, Netflix used RSocket for edge networking because they need really resilient communication, and they had to understand whether mobile phones or browsers are ready to receive data, because in their cases they had like a gateway through which all the internal world was sending all the streams, all the data. So just in case your mobile phone is unavailable for a second or even more, all this traffic were stacked into your gateway, which of course led to many problems for Netflix, which led to some blackout and basically blows up of gateways in their case. So they decided to build their own protocol, which they later became RSocket, in order to have real flow control with the specified number of messages through the whole pipeline, starting from your mobile phone, going through your gateway, and ending up at the specific server. Facebook is using RSocket in the same way. So many mobile clients are connected to query service, and then many mobile applications and browsers are querying data and stream that they really need. And of course, they have this capability to control all the flow, so any part of the system won't be required to buffer any message at all, which is great. You have this guarantee. Another use case, of course, is machine-to-machine communication. You have benefits such as peer-to-peer communication, which means that it's enough for only a single server to obtain connection, and then the rest of the communication can be done in both directions. So you don't have any limitations which you have with, for example, HTTP2, which is in fact client-server protocol. So you can do something like pushbacks, but pushbacks is not real streaming. It requires a client to do a first request first of all, and then pushbacks are limited to a single message, which is not convenient for machine-to-machine communication. And RSocket solves basically this problem. As it was said, both client and server are required just to open the connection, and then both of them can implement some request handling logic, and both of them can ask each party for some data, which is great, of course, and which solves problems like ingress data streaming, where you have like your VPC cloud, every service is hidden behind the firewall, and then you have to be asked by Prometheus, which for example is uploaded, or which is deployed on a separate machine which is outside of your VPS, or even more, it's deployed on the separate cloud which doesn't have like VPS connection or like the same network with your system and with your microservices. And then in that case, you either have to solve this problem of doing a lot of DevOps, or you can easily open a connection from your internal world to your Prometheus, and then Prometheus can start asking your services through the open connection, which is really great. And actually, there is RSocket Prometheus, which does what I say. So this is just a couple of use cases, but from my point of view, RSocket is a really great solution for today's cloud native and cloud native application problems. And having RSocket Broker, which is another part of our RSocket family, you can solve even more. But yeah, RSocket Broker is another story.
Yeah, and there's something to be said also about thinking about in new ways, right? Like there are certain things that we can do with HTTP, like a request response, and we can do streaming to a certain degree. But with WebSocket, I think the strong benefit that you get is that streaming is really well supported with all the bells and whistles, including keep alive and making sure that connection is running. You have reconnection for streams. You have also back pressure, right? So that's reactive streams back pressure across the wire. So for any scenario where you need to stream, essentially RSocket supports the reactive streams main goal, which is for a producer not to overwhelm consumers. So if you're streaming, large amount of data, that means that the client actually has the ability to push back against the server and to make it slow down, which reduces the need for queuing, for having message queue in the middle or something that's going to buffer and absorb large amount of messages. So yeah, again, any kind of scenarios that involve streaming and also in both directions, that's going to be a really, really good fit. Okay, next question is, how does RSocket compare to Grpc? I think that's a good question to try compare and contrast, because Grpc is kind of well known, and yeah. So what's your take on that? Who wants to go?
Yeah, I mean, I can quickly do the answer. Grpc is great. It's basically built on top of protobuf RPC. So basically, all the magic that you get is protobuf RPC service definition and message definition as a like message protocol and message format protocol. And then Grpc let you generate all the stops, all the cool stuff in different languages. different platforms, which is great. By default, and this is basically the only implementation that Grpc has by today, is all these things on top of HTTP2, which means that all you have is basically all this coolest generated stuff, all your RPC messaging, this API, and so forth and so on, define it on top of HTTP2. And then HTTP2 just drive your frames back and forth, which says that we have HTTP2 limitations, and I don't want to talk about it again. But yeah, a part of that, this is just normal HTTP2. On the other hand, RSocket is the same coolest as HTTP2. It brings all the features of HTTP2, plus it brings reactive streams, semantic, plus it brings a little bit better resilience, plus it brings flexibility because now you are not bound to HTTP2 and you can use TCP or WebSocket if you wish. Then imagine if you have this ability to do all this generation, all this protobuf RPC, but run on top of RSocket. Then you will get the same Grpc, but with RSocket. So you will get both at the same time, and you will get double benefits. So basically, you have this today. We have RSocket RPC, which is basically integration of RSocket plus protobuf RPC. So you have the same steps, but underneath everything is run on top of RSocket. So that's my answer. Grpc is a cool idea. It's limited to HTTP2, so having RSocket as a transport for all this code generation will improve Grpc and will make it even better. So we have RSocket RPC, which is basically this idea. Yeah, this is my answer.
Okay, folks, thanks a lot. And I just want to say very big, great, thank you for this talk. And let's continue our discussion in Zoom meeting. All the attendees can push a Zoom button just under the web player and join a Zoom discussion with Rosen, Oleg, and Mark. And again, folks, it's a great honor for us, for our team, and for our attendees, for all of Joker guys, to have you on board this year. Thanks a lot.